Now we come to the type of gearboxes. These are sliding mesh type gearbox, constant mesh type gearbox, we understand double declutching associated with constant mesh. Then we will also see the latest, which is now being done, made and fitted, Synchromesh gearbox. And finally we'll see the lubrication and care of the gearbox. Now sliding mesh type of gearbox shown here, the simplest type. Now we are inside the gearbox. There will always be two shafts. If you have seen a gearbox, open gearbox, workshop on the roadside or other ends, the top one will be the main shaft, and the lower one will be called is the lay shaft, or even some call it the counter shaft. The drive is coming from the engine, propeller shaft, clutch shaft. There is a gear which is called clutch gear, which is fixed to the clutch shaft. And fixed to this clutch gear is also a gear on the lay shaft, which are always in contact. Which means that whenever you start the engine in neutral position, the power will flow and the lay shaft will start rotating along with the clutch shaft, clutch gear and lay shaft. Now the gears, with various sizes gears, number of teeth, this is important, which you will study later. Number of teeth, that's why the sizes are different. These gears are fixed onto the lay shaft. Two gears are mounted on the main shaft. The main shaft is supplying, and therefore these two gears are free to slide on the main shaft. Now let's see the first gear. The first gear flow, as we said, we start in neutral, will be this. The gear selector mechanism, the gear lever on top of the gearbox will be shifted to the first gear, means this gear will come in contact with this, and the flow will be from here, this gearbox output shaft going to the propeller shaft and various the drive, rest of the drive. Now we want to shift to second gear. We will press the clutch, disengage this and put it in second gear. What do we do in the second gear? In second gear, the gear lever mechanism will shift this gear on the splines will shift and come in contact with this gear. So how will be the power flow? From here, 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 here and out of the gearbox. Top gear, third gear or top gear. Press the clutch, remove this, and the clutch selector mechanism shifts this gear into the clutch gear. This is internally splined, this is internally splined also. And the drive is direct drive, which is the top gear. Direct drive, although this will continue rotating, this is always rotating as I said, but the drive will be this, there is no drive from here, and the drive will be straight. Now what about the reverse? We have to move the vehicle in reverse also. For reverse, this is the first and reverse gear, this is shifted to the right. This is shifted to the right. The difference is that between this gear and this gear, there is a idler gear. The idler gear, what is the purpose of idler gear? Is to turn the direction of rotation. If it was clockwise going on, the idler gear will make it turn clockwise, anti-clockwise. Earlier semesters must have learned to turn the rotation. You put an idler, so that what will be the flow? Come from here, through the idler gear, this will reverse the direction of the main shaft, and the main shaft, instead of clockwise, will start rotating anti-clockwise, and the vehicle will move backwards. Now we come to the constant mesh type gearbox. The constant mesh gearbox is similar to the extent that this is the drive coming puller shaft to clutch shaft. The clutch gear, as same, is always connected. Even this lathe shaft, all the gears on the lathe shaft are also fixed. But in addition, these gears also are fixed to the gears on the lathe shaft. What moves? The main shaft is flying for the movement of these sliding dog clutches. Now there are two sliding dog clutches. If you have 3 gears, there will be 2 sliding dog clutches. Clutches are these small things which come first into frictional contact and then they contact that particular gear. So gear shifter mechanism is fitted onto these, and when you shift it, only this moves left. These don't move, these are fixed to the gear below. This will move left or right. This will move left or right. Now let us look at the first gear. The drive comes this way, same as that, onto the lathe shaft. And for the low gear, the right dog clutch is moved left and making contact with this, and so the power will flow. Now this is the low gear, first gear. Now we want to shift to the second gear. We press the clutch, this gets disconnected, and the gear selector mechanism, we shift the left dog clutch to the right. This contacts this, and the power flow will be this is the second gear, power flow. For third gear, same as that. You press the clutch and then engage the gear selector mechanism to top gear. This dog clutch will be moved left, and these clutches will engage, and the drive will be direct. As in that, this is also, but there will be no flow. There will be a direct flow for the top gear. For the reverse also, it is the same. This is the idler gear, and the direction rotation of the main shaft will reverse, allowing the vehicle to move in the reverse direction. Now, what is double clutching? Relevant to this. We'll read it. For smooth engagement of dog clutches, for smooth engagement of these clutches, we must synchronize. Try to bring the speed of the main shaft and the dogs as nearly close as possible to avoid friction and noise and all that. For smooth, speed of the main shaft and the sliding dog must be equal. So how do we do that? We do that by doing a double declutching. What happens in that? We press the clutch, bring to neutral, press the accelerator with the right foot, so to increase the speed of the main shaft to that of the dog clutch, so that both can engage, and then again we engage the gear and release the clutch. So it is called the double declutching. So the speeds should be the same to avoid any noise, friction, all that will be avoided. Now let us look at the advantages of constant mesh sliding over the sliding mesh. This sliding mesh is virtually I think the production has stopped totally. This is also limited quantity. This has been now, the latest is of course the Synchronous gearbox, which is a slight improvement over this. But we must know, theoretically, you must know the concepts, must be known. So the advantages of constant mesh over this are, first, you can use helical gears because the gears are always in mesh. And as we know, you have studied in the earlier semesters, helical gears are less noisy. As always best, it has quieter operation too. The wear of the dog teeth is reduced as all the teeth involved compared to only 2 to 3 teeth in case of sliding mesh. In sliding mesh, only these 2, 3 teeth come in contact whenever you contact them. These are always in contact, only the dog clutches are functioning in this case. So, the wear of the dog teeth are reduced as all these teeth are already meshed. So there will be less wear on the dog. Now, Synchromesh gearbox. Synchromesh gearbox is an improvement over the constant mesh gearbox. The construction is similar, that we have a main shaft which is splined and the lay shaft, fixed gears, everything is the same. The only addition is that there is a synchromesh device. The synchromesh, what is the purpose of that synchromesh device? But all that it does is it avoids the double declutching. The job we have to do physically in double declutching is done by the synchromesh device. We will study in the later when we come to the particular study of the gearbox inside. I'll read it similar to construction of the constant mesh gearbox with meshing of gears of main shaft and lay shaft, same. Working also similar, except one improvement, provision of synchromesh device which avoids double declutching. Parts to be engaged are first brought into frictional contact. Equalizing their speeds. Once their speeds are equalized, automatically, which we have to do in declutching, and then they are engaged with the gear lever, then you engage. First, the synchromesh device works. Once the speeds are matched, then the gear selector mechanism, through the gear lever, we engage the gear, that particular gear. Lubrication of gearbox, this is important, related to this. I thought some relevant points which should be known. First is the gearbox should always be kept filled with lubricant to avoid metal-to-metal contact. Metal-to-metal contact, the gears we have studied earlier. There is always a thin film between two gears when they are running, because the gearbox is full, and that is the lubrication required. If that is not there, there is no oil. The meshing of the teeth will cause the gear teeth temperature to rise very high, and the gear teeth may burn out. So, to avoid metal-to-metal contact, as heat generated would burn the gear teeth, even a low level is dangerous. Partially it may take longer, but eventually the gear teeth will burn up. So, we need to top up every 1600 kilometers. This is the older vehicles, now of course kilometers increased. Oil change must be done 30 to 40,000 kilometers. Oil change, I would like to mention, this nowadays modern cars, anything around 60 to 80,000. And in some cars, like my car Ford, Fiesta, they say there is no need to change the gearbox at all during the entire service. Unless there is a problem, then only the gearbox is open and the oil change. Otherwise, no need. Why is this so? Whereas the engine oil, sump oil or engine oil is changed every 30, 40,000. This is not changed at all or changed 80,000. The reason is the engine oil in the sump is contaminated by blow-by. We studied in the last lecture, blow-by is what? The unburnt gases and the burnt gases inside the cylinder bypass the piston rings and enter into the sump, which contaminate the sump oil. That is why we have to change the engine oil more frequently. So the procedure is drain, flush and refill.